Right, boys, we're going to look at area of a triangle today, and we're going to use something called the area of a parallelogram to prove the formula for the area of a triangle. But first, we must understand what the base and the height of a triangle actually are. Now, any side, any side of a triangle, let me just colour this in just for fun. Any side of a triangle can be called its base. Okay, so we're going to write that down on our triangle down here. So what I'd like you to do is to come down to the first triangle, and we're going to call this the base. Okay, so the base is any side of a triangle. So in this case, we just drew the base. So this side here, I'm going to call that the base. But it doesn't have to be. It could be another side. So for example, we could do another side. Let's say this side is the base. Okay, so let's label that side the base. So base. And last of all, let's label a different side the base. So let's label this side here the base. Okay. All right, so label this side here. So any side of the triangle can be the base. All right. Now what about the height of the triangle? Okay. The height is the distance from the base to the opposite vertex. Okay, the distance from the base to the opposite vertex. Now what's a vertex? Vertex is just a corner of the triangle. So here's my base in the first triangle. So if I take I need a ruler for this. I want to draw a line from the base to the opposite vertex, and it's got to be at right angles. Okay, so that's the key word there. The distance is measured at right angles to the base, right? And because of that, we call it the perpendicular height. Perpendicular meaning at 90 degrees or at right angles. Okay, so let's draw, starting from the base. I'll start from the corner here. That's the opposite corner. I'm going to draw a 90-degree line. So it's going to be a line which is vertical to the base, and it touches the opposite vertex. Okay, so this here, this corner here, that's called the vertex. Okay, that little corner that we started from is called the vertex. Now this here is the height, H for height, and this angle here is 90 degrees. We use a little box for that. We've seen that before. Now that pink vertical line there is called the perpendicular height. Perpendicular height means a height which is at 90 degrees to the base. Okay, now let's draw another height in. So to draw another height in, we have to start with the base here, and we go to the opposite vertex here. And we're going to draw a line from the opposite vertex to the base. It can't be at any angle. These are all different angles. It's got to be at 90 degrees to the base. So that's about right. 90 degrees to the base. And it's starting from the opposite vertex. There we go, just to fix it up a little bit. All right, so let's mark that angle in there. This angle, if you've drawn it correctly, should be at 90 degrees. Okay, that is the height of the triangle, and there is my base. Now let's do the other height. Now here's my base, here's my opposite vertex. So I'm going to start from the opposite vertex. And when I get my line, just watch, it's got to be at right angles. So I've got to make sure when I move it, that I'm moving it so that it's at 90 degrees to the base. That's about 90 degrees there. So that angle there is 90. Rightio. So let's mark that in there. This is 90 degrees. Okay, and that's the height. the perpendicular height. Now let's come down to all these right angle triangles here. Now let's do the same idea again. Any side can be the base. So let's call this the base. Over here, let's call this the base. Then over here, we'll call this the base. Let's see if I can write upside down here. Right, there we go, base. Okay, so we've got 3 different bases, and just like before, let's colour them in. Okay, so here we go, here's my highlighter tool. So here's my first base in the green. Here is my second base in the green, and here's my third base. So any one of these, any side of a triangle can be the base. Now, the height can't be any side. The height has to be at 90 degrees to the base. Now you can see here that this line is 90 degrees. In actual fact, for the right angle triangle here, let's just change colors for a minute. This is the height here. Okay, now, because here's my opposite vertex. The vertex, or the corner opposite the base at 90 degrees, is that side there, so that's the height. It's called the perpendicular height, don't forget. Now what about this one? Here's the base, but here's my opposite vertex here. So I've got to start from there, and then I've got to draw my line in, which is my height. Okay, so let's do that. So I'm going to start from the opposite vertex, and now when you draw your line, make sure it's at 90 degrees. That'll do. 90 degrees to the base. Okay, and then over here, here's my base, but what's at 90 degrees to my base? Let me just draw the line in. Here's my opposite vertex, so this side is the height here, that side there. Just like over here, this is the height here, the other one. Okay, so for a right angle triangle, those are the 3 possibilities. So let's just make sure you've got the height written in there. So you should have the letter H written for the height. So height there and height there. Now, what about an obtuse angle triangle? So here we've got 3 different obtuse angle triangles. So let's start with the base again. So any side can be the base. So let's start off with this side. So here's the base in the first triangle. Here's the base in the second triangle. And then here's the base in the third triangle. So any side can be the base. Now, we've got to mark in the perpendicular height. Now, let's think about this. For the first one, where's the opposite vertex? The opposite vertex to that green base there is here. Now, if you get a line now and try and draw a right angle triangle from there, you can't do it. Now, wherever I can't get a 90 degree angle from here. So I'm going to have to come down to here. Okay, so, and that means the height for a obtuse angle triangle, I'm just going to extend the base line with a little dotted line here. And just be aware that this dotted line is not part of the triangle. Okay, so that's my 90 degree angle. And let's just rub out the pink line for a minute so I can get it accurate. Okay, so from here to here, there we go, there's my height. So for an obtuse angle triangle, you've got to be aware that the height is the distance from the vertex to the line which contains the base. Okay, so there's my 90 degree angle. That little dashed line is just extending the base there, but it's actually not part of the triangle. Okay, now what about this one for the second one? Here's my base here. Let's just put base this one here. Now here's my base in the green there. So base is here. Here's my opposite vertex. So I need to draw a line which is at 90 degrees to the opposite vertex. So let's try and do that. Okay, again, I've got the same sort of problem, don't I? Yes, I'm going to have to extend my baseline again, all right? So let's say roughly about there. So I'm just going to put a little dotted line. I'm going to extend the baseline. Okay, so just down here. So a little dotted line. And that should be a 90-degree angle. There we go, 90-degree angle. So maybe not, that doesn't look quite right, does it? It doesn't look quite 90 degrees. So let's try it. Let me just try that again. If I have, let's just extend the line here for a minute. I'm just going to draw that line there, and then it'll be easier by eye to get this here. So it's maybe around about there. That's better. Okay, so I'll just get rid of that part there. All right, so my baseline goes out a bit further. So let's just erase a little bit there. And the baseline should come just a little bit further out to meet that height. Let's just dot that in there. Okay. All right, so there's my 90-degree angle. This is the height. And just be aware the base is just a green length only. Okay, that dotted line is not part of the triangle. And there's my height. It's called the perpendicular height. Now this will be easier. Here, this one is the base. And the opposite vertex, the opposite corner to the base is here. And that means when I put my height in, it's going to be easier. There we go. That's nice and easy. There's my base. Make sure you mark in your 90-degree angle and make sure you put in your height. Okay. Right, so there's the base and the height of any triangle. An acute angled triangle, a right angled triangle, and even an obtuse angled triangle. Okay, so just for the last bit, for an obtuse angled triangle, right, so for an obtuse angled triangle, the height can be the perpendicular distance, which is the 90-degree distance, from the line extending through the base to the opposite vertex. Okay, so the line which extends through the base, which is that dotted line, the perpendicular distance from that to the opposite vertex is the height. Now, by the way, just for your notes, you should write down that perpendicular means 90 degrees. Okay, so perpendicular means at 90 degrees. Okay, that's the meaning of that. All right, let's have a look at the formula for the area of a triangle. Now, here we've got a parallelogram, and in the previous lesson we looked at what the formula for the area of a parallelogram is, didn't we? Remember we said that area of a parallelogram is base times height. Now, this parallelogram is made of two of these triangles over here, okay? So that parallelogram is made up of two of these. So there's this part and this part. They're both the same area, right? So two of these triangles makes this parallelogram, which means we could just shade that in nicely. So this area here, I'll just shade that in. So this area here and this area here is the same, okay? So, and because we've used two of these triangles to make the parallelogram, that means the triangle itself must be half. Okay, so the area of this triangle is half the area of that parallelogram. So area equals half the base times the height, or a half times the base times the height. Or we could write this as base times height, base times height, divided by 2. Okay, so this parallelogram is base times height, and the parallelogram is made of these two of these triangles. So the triangle is half the area of the parallelogram. Let's look at this one. Okay, so we've got an obtuse angle triangle here. So one of these, right, is duplicated to form this parallelogram. So this parallelogram is made of two of these individual triangles. Okay, and we know that the area of the parallelogram is base times height. Okay, and since this area is half the area of the parallelogram, and this is the same area here, we can write down that the area of the triangle is a half the base times the height. Okay, of the parallelogram. Okay, coming down here, we have a rectangle. The rectangle is made up of two of these right angle triangles. There's my right angle there. Okay, so the area of this triangle, or sorry, this rectangle is base times height. Now, this area here is half the area of the rectangle, and this is the same area over here, which means the area of this right angle triangle is a half times the base times the height. Right, so if we were to label the base and the height there, so base is here, height is there, base is here, height is there. Coming back up here, we have base here, and height there, and same here, base is here. I can extend that a little bit further. Coming down, that's the height, that's 90 degrees. And then last of all, we have, I'll just have to rub this out for a minute. We have the base, which is on the bottom here. And we have the height, which is there. And same over here, we've got the height. So what we can see is that the formula for any triangle is a half the base times the height, or just base times height divided by 2. So any type of triangle, it's all the same formula. Okay, so we're going to write that down as a summary down here. So for our summary, okay, we're going to put in a dashed line there for the height. This is the base, put a little right angle there. This is the base, this is the height. Now for this one, we're going to have to just extend that baseline a little bit and then do a vertical line down from the opposite vertex. Okay, that's the height there. That's the base. The base is just from here to here. And they all have the same formula, okay, which is area is base times height divided by 2. Area is base times height divided by 2. And area is base times height divided by 2. Okay, all the same formula. So let's have a look at 2 examples. Right, I want you to try these 2 questions. So area is base times height divided by 2. So that's going to be, well, here's my height. Here is my base. That 7 is irrelevant. We just need the base and the height. Now the base and the height have to be at 90 degrees to each other. You can see that there. There's a 90-degree angle. Divided by 2. And that should be 48 divided by 2. You can just use your calculator for that. So 48 divided by 2. And that's 24 square meters. Okay. We'll try the second one. I'd use the same formula, base times height divided by 2. Now the base here is 4.2. The height is 3. Divide that by 2. Okay, so that's going to give you, you can use a calculator, of course. There we go. It's going to give you 12.6 divided by 2, which is 6.3, and it should be centimeters squared. Okay, so that's the area of a triangle.